Hey everybody, welcome back to Young Engineers of Today. So we're going to continue with Python today, but we're going to do a little bit different than we've been doing, I guess you guys did on Monday with Mr. Dubik. I know you guys went over Turtle and stuff like that through the Python shell. We're actually going to go over um, writing a program and then running it through the terminal. So, like I said, a little bit different from what we did on Monday, or what you did on Monday, I guess. And maybe a little bit drier, I'm not going to lie to you, but you'll get a better feel for the sort of how a program is structured and the flow of it and stuff like that, at least for a simpler program. Um, and we'll go through sort of like the building blocks that all work together in order to make a functioning program. So without further ado, why don't I go ahead and close that out because that was from the middle school one. Okay, so everybody should already have Python installed. The basics of this is really we're just going to open up a plain text editor and start writing in it. If you're on Windows, Notepad does the trick just fine. If you're on a Macintosh operating system, you can run TextEdit. You just have to make sure to set it to plain text mode. It's just going to be a simple number guessing game. Nothing crazy at all. It's gonna ask you to guess the number that it's thinking of between 1 and 20 within a certain number of guesses, and that's all. So I'm going to go ahead and open up my plain text editor of choice. One other point, raise your hand if you're running on a. Do it this way, just so that we have, because this is actually more like traditional programming as well. So you could do it through the Python shell, but this way we at least know how to execute it like otherwise, like you would maybe if you're writing something in another programming language. Okay, so show of hands, how many of you are running on like a Mac? Okay, so when you open up TextEdit, you're not going to run a program in TextEdit. That's where I'm going with this. When you open up TextEdit, you have to make sure that you're running in plain text mode. So the way you do that is after you open it up, at the top, you're going to have format, and there's going to be an option, I believe it's called make plain text. And then your font's going to change. It's going to look something like that, and that's how you know you're running in plain text. But that was an excellent question, Mateo. How do I run a program in TextEdit? The answer is you don't. But this is a lot like how traditional programming is done. So getting a feel for this as well is going to help you get more comfortable with doing a more traditional programming thing as well. Like the Python shell is fantastic because it's great to have that integrated sort of Python compiler and everything like that, interpreter. But this is going to be something a little bit different. Because with a programming language like Java or C or something like that, you're going to have to compile the program, which means that you're going to have to turn it into machine language that the computer can then run, which means that your editor, unless you're running an IDE, is generally not going to be the same thing that you run the program on. So it's a little bit different. But anyway, so this program is just going to be comprised of a couple of method calls, a loop, some if statements, and some variables. And that's it. It's going to be a really pretty simple program, but it's going to be nice because we're going to be able to see how all three of those things work together. That is to say, control flow and loops and variables work together in order to create an interactive program for a user. So we're going to start out really simple. We're going to create a variable called guesses taken and set it equal to 0. And that's it. That's the first thing we're going to do. Because everything's got to start somewhere, right? So in this case, we're going to start off with a variable. So I guess go ahead, just so I don't leave anybody behind. I know this is a single statement, but Go ahead and raise your hand once you've gotten your text editor of choice open and you've gotten at least this typed out. All right, that's just about everybody. Raise your hand if you're still opening up your text editor. Raise your hand if you're typing out the statement. Okay. All right, well, the statement's pretty straightforward. It's just guesses taken with a capital T, all one word, set equal to 0. So at least that. But that's going to be our starting point for this program. Next, whoops, I'm going to just drop down here so that I have the source code. So guesses taken, and then you guys are all running Python 3, correct? I believe you should be. Yeah. Okay, cool. I just wanted to make sure because here's the other thing. We're going to create a variable called myName, and we're going to set it equal to an input call. Now in Python 2, this would be raw input. As opposed to just input, it would be raw underscore input. But since we're running Python 3 and later than 3.2 specifically, it's just going to be input. So all this is doing is it's taking input from the user. They're going to type something on their keyboard, and they're going to press enter, and it's going to be put into the myName variable. In fact, this is technically a working statement. However, we're going to put some stuff inside the parentheses because whatever we put inside the parentheses is actually going to output to the terminal as sort of like a prompt for the user. So we're going to say, what is your name? With a space and then closing quotes and closing parentheses. Because if we don't do this, if we just have this blank, so far all our program's going to do is we're going to run it and it's going to print out a blank line to the screen. And it's going to sit there and not do anything because it's waiting for the user to input their name, presumably, or at least something. But the user doesn't know that. So they think that maybe it's just frozen or something like that. So what we're doing is we're making it more user-friendly. We're making it more helpful to see what's going on. So my name equals input, what is your name? And then we're going to say, we're going to print a response to the screen. We're going to say, well, my name, I am thinking of a number between 1 and 20. Close quotes, close parentheses. So all print does is it just prints to the screen. But what exactly is happening right here? Well, we can take this apart. The stuff over here, anything inside of double quotes on a print of any sort is something called a string literal. So all it's doing is it's just printing out exactly what is in between the quotes. So what is your name, question mark, space? As is the case here, well, comma, space, and then comma, space, I am thinking of a number between 1 and 20, period. It'll print that out to the screen. But this in the middle here, what it's doing is it's going to stick in between these two sets of strings, string literals, it's going to stick the myName, the contents of the myName variable that the user filled just in the last line. And these plus signs enable the computer to sort of slap it together into one long string statement. The fancy name for it is concatenation, but basically it's just taking the well, and then it's sticking the myName to it, and then it's sticking the rest of the statement to it. So it looks like a coherent statement. So far, it's asking the user what their name is, and then it's printing a response. Well, I am thinking of a number between 1 and 20. In fact, let's go ahead and save this real quick. I'm going to save this as guesses.py. So what I'm doing is I'm saving this plain text document as a .py file somewhere on my computer. And it's very important that you make sure that it's saved as a .py file. Otherwise, the computer won't know that it's a Python file. So guesses.py, and I'm going to click save. And I'm also keeping track of where it's saved. I'm going to save it on, I'm going to save it in my documents folder. So we'll hit save, and there we go. So far, we've got something. Now let's see how this runs. Let's go ahead and run it real quick. So what I'm going to do is I'm going to open up my computer's terminal. If you're running on a Macintosh computer or a Linux computer, you can open up the terminal. You can just do the search in the upper right-hand corner, or the command space, I believe, also brings up the search. And then you can just type in terminal, and you should get the first result is exactly what you're looking for. It's going to be the text prompt. If you're on a Windows computer, if you're on Windows 8 or Windows 10, you can right-click on the 8.1 or 10. You can right-click on the little Windows icon on the lower right-hand side, and you can see Command Prompt or PowerShell. So I'm going to open up the admin command prompt, because running it as admin just ensures that I can run something from the command prompt, and I don't have to get permission from the computer, or the computer doesn't have to get permission from me again in order to run it. So now I am sitting at the command prompt. You might be sitting at the terminal. And as you can see, it sticks us within a specific spot on the computer. And in my case, it's C Windows System 32. And this is simply just, we can navigate to this through the, let's open up a new window here. File Explorer. So if we go to C, Windows, System 32. And there we are. This is exactly where we are on the command prompt. So what we want to do is we want to navigate to where we saved our file, in my case, in the Documents folder. I can use, since I'm on Windows, dir to see the contents of any particular folder I'm in. If you're on a Mac or a Linux computer, you can use ls to see the contents of whatever you're in. I believe you can also use dir on some Linux distributions. Anyway, so now if I type cd and then a space, and then a file path, I can go to that location. CD is short for change directory. That's what that is. CD is universal from Windows to Linux to Mac, so you guys can run the same command and change it as well. So what I want to do is, now I'm sitting on C, and I want to hit dir to see where exactly I want to go. If you're on a Mac or a Linux computer, you can actually type cd space and then a tilde, which is the little squiggly line above the backtick on the upper left-hand part of your keyboard. So just hit Shift and then the key just to the left of 1, and go there, and you'll be able to go to the home folder, which is the same thing as the users folder on a Windows machine. But yes, so I'm going to go to CD capital U to go to users, and I can hit tab in order to complete it. That's a handy little trick. Anytime you're running on the terminal and you start typing something, you can use tab to complete the rest of it without having to type it all out. It might not do it, and if it doesn't do it, that's because there are probably a couple things it could be completed to. Like if I typed U and then hit tab and it didn't complete, it could be because I have users, but I also have ukulele. And it doesn't know whether I want to use one or the other. But I only have users here, so I can hit tab and complete it. So I'm going to hit users, and now I'm sitting in the users folder. I can hit the directory, and as we can see, we got a listing of users here. Change to mine. No comments. And then I'm going to change to interesting. That's an interesting folder. I'm going to change to documents. Nope. Documents. Boom. And now we're sitting in the documents folder. And this is where I saved my file. If you saved yours in the documents folder and you navigated to it, awesome. You can move to this next step. If you're still navigating to the folder where you saved it, that's fine too. just pay attention to what I'm doing here. If you're not sure where you saved it, go back to your plain text editor and hit Save As and see what it defaults to. As you can see, it defaults to Documents. And then make sure that you saved it there. But yeah, so I'm in my Documents folder, so now I can type guesses.py and run what we have so far. Now it's going to say, what is your name? My name is, well, it's Thomas. I'm a head editor. And it says, well, Thomas, I am thinking of a number between 1 and 20. Wow. Really interesting and interactive so far, right? In fact, we could run it again. My name is now going to be Thrumbo. And it says, well, Thrumbo, I'm thinking of a number between 1 and 20. Now my name is Ivan. Well, Ivan, I'm thinking of a number between 1 and 20. You get the idea. All it's doing is it's just slapping whatever we told it to in the middle there. So far, so good, right? Keep the terminal window open and go back to your plain text editor. We're going to add a little bit more to this. Didn't work for you. Did it throw back an error message? Okay. The thing that you want to do is you want to navigate in your command prompt or terminal to where you save the file and then just run the file by typing its name while you're in that folder. The term guessinggame.py is not recognized as the name of a commandlet function, script file, or operable program. Check the spelling of the name, or if a path was included, verify that the path is correct and try again. At line 1, character 1, guessinggame.py. Did you, by any chance, do that at the beginning of your file, Jean-Marc? You kind of got lost with navigating through the folders, or oh, you got it to work? Okay, excellent. Opening the program. But okay, so where did you get lost in the process? That's what I mean. What have you done so far, and what do you need to do next? Okay, what do you need to do next? Do you need to navigate to where the file is? Or are you already where the file is? Okay, do you have command prompt open? Are you currently in the folder where your Python file is? Okay, type the name of your file, like I did here, guesses.py. I mean, whatever you named it. You could have named it guesses.py, you could have named it magic.py, whatever. But type the name of your file and nothing else, just name of my file.py and hit enter. It says it doesn't recognize it. What is the specific prompt that or error message that it's throwing back at you? And you named it guesses.py? Um, okay. Because it should be. Can you hold on? Oh, interesting. Okay, so it doesn't work in the command, or excuse me, it doesn't work in the PowerShell. All right, so you'll have to run it in the command prompt. I did not realize that, Jean-Marc. That was a mistake. I apologize for misleading people. Um, Harry and Levi, are you running it through the command prompt or the PowerShell? Do you have a black or a blue background? You have a black background. Command. Okay. No worries, Tim. You might want to watch the YouTube video um, later on, just so you understand where we stand so far. Okay, so you guys are both running a command prompt and it's not working. That is not ideal. If you and you guys went to you guys saved it in your documents folder. If you hit like dir, you can see it sitting there, right, in the folder that you're in. Hmm. This is Yeah, that's what I was referring to. Okay, this is not ideal. Uh, Chances are it's not. Okay, so your computer is not recognizing Python as a valid interpreter for .py files, and that's a little bit annoying to get fixed. But we can potentially spend some time after class getting that up and running. At the very least, you can walk through the writing of the program with us, so that when you do get up and running, um, we can command not found. Oh, right, you're running on a Mac, aren't you? Okay, and you're definitely in the location where the file is. Man, I don't understand why this is given the high school class so much trouble. Okay, yeah, we'll have to check that as well. Okay, all right, that's something we can try and figure out at the end of class. But same deal, Mateo. Just at least follow along with the text file so that you know what we're doing, and that when you get the Python interpreter linked to .py files, you'll be able to run them as well. Okay, so yeah, we've gotten so far as asking the user for a name and responding with a statement that uses their name, which is pretty wild, right? Now we're actually going to randomly generate a number between 1 and 20, including either 1 or 20. So we're going to say number equals random.randint 1, 20. So what exactly is happening here? Okay, We're taking a value from a function and we're throwing it into the number variable. What is this function? Well, this function is called randint, and that's just short for random integer. That's all. And then the value in the parentheses, it's a minimum and a maximum value that this random integer can be. So it's going to be somewhere between 1 and 20, including 1 and 20. That's all that is. Now, there's this random dot in front of it, though. So what exactly is that? Well, all we're telling the interpreter is that you can find randint within the random library. There is a library called random which provides a whole bunch of pseudo-random, numbers and value or like whole numbers and floating point numbers like decimal numbers and stuff like that. But that's what we're telling. We're telling Python to find it in random, which doesn't really mean much to us. Oh, you got it to work? Awesome. Um, you did too? What'd you end up doing? Just so I know. Because I was thinking that it was going to be the Python wasn't set as the default interpreter, but must have been entering the wrong things. Oh, okay. Hmm. All right. Well, thank you, Levi's mom. Oh, yeah. You have to change directory all the way to the exact location of the file. Definitely. Yeah, but I'm glad you got it. All right. Okay, so yes, it's part of the. Okay, Tim. No worries. Hey, no worries, Levi. It happens. The really tricky thing is it can be hard to help sort of troubleshoot um, strictly over voice and stuff like that, or voice and text chat, as the case may be. Um, so having somebody in person to help you out can also help immensely. So thank you again, Levi's mom. Um, and I'm glad that you got it up and running. So that's really the important thing. But yes, the random library. What do I mean by that? Well, libraries are you got it excellent, awesome. You just have to navigate to the folder, Harry. Ah, yeah. I get you. Well, there we go. All right. Well, we'll get you up and running at the end of class then, Mateo. So, what is a library? Well, a library expands the functionality of a program and a programming languages. You got it? Awesome. All right, so that's everybody, presumably. Fantastic. Excellent. I like seeing this. Um, but yeah, so it expands the functionality of a program. What do I mean by that? Well, okay, so let's use an example. So in the C programming language, fun fact, in the base C programming language, or you put it directly in Python? Gotcha. Um, all right then. There is no functionality in the base C programming language to write anything, input, out, or excuse me, variables, words, letters, numbers, whatever, anything to the screen. Nor is there, in base C language, any functionality to take input from a computer keyboard. There is no ability to write to the terminal or get user input from a keyboard. It doesn't exist. So if you're to write a program in C, and they do this because they don't want to assume anything. You could run C on a little airplane black box, and it's never going to output things to a screen, so you don't have to write that information in there. But anyway, if you ever wanted to write a program that wrote, that is doing what we're doing here in Python, you would have to basically write a whole set of functions that write letters to the terminal screen and take input from a user keyboard and stuff like that, and all this kind of stuff. And it's a big old pain, except for the fact that there are people out there who went, yeah, I'd really rather not have to do that every single time I write a program in C. And so they basically wrote a set of functions, and then they saved it as what's called a library. And a library is just a set of files that you can then reference in your code. So anytime you're writing something in C that then writes to the screen, you can include the standard input-output library, which will have all of that functionality already built in. And so then you can tell it to print to the screen and take input from the user and blah, 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 without having to reinvent the wheel every time. The random library in Python includes functionality to give random numbers. But we have to include the library. We have to import the library into our Python program, which is simply done by putting it at the top. Import space random. And that's it. Literally doing that will import a pseudo-random number generator into our Python program, which we can then use to get a random number. In fact, there's a bit of a running joke with Python that Python's very modular. And the running joke is that, Python supports time travel, just import time travel. Or, Python supports Armageddon, just import Armageddon. Like, there are so many things that you can just randomly import in Python and include for functionality. And people are always writing their own Python libraries and stuff like that you can then include for whatever, import for whatever. So Python is a very modular, very, very programmer-friendly language in that respect. So import random will do exactly what we want it to do. It will import the random library, which we can then use to get a random number from. So far, we've got a variable called guess is taken with 0. We get user input. We print the user input back. Then we get a random number. Now what? Now we need to actually do the guessing aspect of this. And we're going to use a loop for that. So you remember I was talking about loops last week, and we talked about how a loop works. I'll go ahead and get this loop started again. While guesses taken is less than 6, colon. So while denotes that it's a loop, as you guys probably remember, and guesses taken is less than 6 is our truth check here. So as long as the guesses taken variable, the contents of the guesses taken variable is less than 6, we run the stuff in the loop. The minute that guesses taken is 6, I should say the fraction of a second that guesses taken is 6. It is no longer less than 6, right? So this is no longer true, and we skip the stuff in the loop to go to the stuff after the loop. Right? Pretty straightforward. So you'll notice that I indented it just like we did in Code Combat. You want to make sure that anything that's a part of a loop or an if statement or anything like that is going to be indented from the thing that calls it. So anything inside of our loop is going to be indented at least 4 spaces. Anything outside of our loop is going to be not indented, just like the loop call is. So let's start putting our stuff in our loop. So we're going to say guess is equal to inputs. Go ahead, make a guess. So now we've got another prompt for the user, and we tell them, go ahead, make a guess. And then we store it into the guess variable. Then we're going to do something interesting. Now notice, I am not using tab to import. I am pressing space, or excuse me, indent. I am pressing space 4 times. That's just because Notepad does indenting a little strangely. It should still work, but I'm just being safe because traditionally indenting is also 4 spaces, and that's what Python will also check for is 4 spaces. So I am using 4 spaces manually in order to ensure that everything's indented properly. So guess, this is the next line, and this is going to be the interesting thing. Guess is equal to int guess. What? Well, variables can store a whole bunch of different things. They can store letters, they can store numbers, they can store true false values, they can store a whole bunch of letters all together. They can store information about complex objects. They can store locations in memory to reference for other things. Like as you get further along with programming and stuff like that, the stuff that variables can do is pretty awesome. But the thing is, computers only work with ones and zeros. So how do you interpret those ones and zeros to be a letter or a number or a memory address or an object or whatever? Well, it has to do with the type of variable that it is. Many other programming languages, they keep track of what type of variable is. And that is to say whether or not that variable is holding whole numbers or holding letters or holding whatever, so that the computer can then interpret that sequence of ones and zeros appropriately. Python, in order to make it more user-friendly, more programmer-friendly, does tend to guess at what type of variable you're creating. It guesses based on what you feed it with, what you put into it. So it correctly figures that number is going to be an integer variable because we're feeding it with a random number, an integer number. It guesses that my name is going to be a string or a string of letters because we feed a string of letters into it. It guesses that guess is taken is going to be an integer because we just gave it a 0, which is a whole number. I mean, it doesn't have a value because it's 0, but it's a whole number, strictly speaking. So sometimes it doesn't always get it 100% right, and sometimes comparing things can be tricky. Sometimes strings can also be numbers. So you can have 56 the string, and you can have 56 the integer. And that's where things get wonky, because 56 the string is not actually going to be equal to 56 the integer. And that goes into a whole set of things that's just gonna, that's for later stuff. But as it stands right now, what we want to make sure is we want to make sure that we set our guess variable to be an integer so that we can do comparisons without borking everything. So that's all we're doing is we're turning a string variable into an integer variable so that we can compare it to our number. We're also going to increment guesses taken by 1. Oops, let's just do this. So that every time the loop runs, guesses taken goes up by 1, so that we'll eventually exit and we don't just have a forever loop, infinite loop, an accidental infinite loop. Oops. Then we're going to put in our if statements. So we're going to say if guess is greater than number. One more. If guess is less than number. And if guess is equal to number. And then we're going to fill these with some useful things. So if guess is greater than number, we're going to indent 8 times now, because this statement, excuse me, random coughing fit. Okay. This statement is going to be a part of the if, or excuse me, this next thing is going to be a part of the if statement, just like everything so far has been a part of the while loop. So we need to indent it further in order to tell Python that it's a part of the if statement. So I'm going to indent it with 8 spaces. And we're going to say prints that number is too high. If guess is less than number, well, that number is too low. Pretty straightforward, right? So if guess is greater than number, we're going to print to the screen that number is too high. If guess is less than number, we're going to print that number is too low. Now, if guess is equal to number, we're going to do something strange. We're going to type the word break. All break does is it tells us to get out of whatever loop we're stuck in, regardless of whether or not this is true or false. If we break out of a loop, it is going to move on to stuff after the loop without checking to see whether or not this is true. It's never going to touch this statement again unless we call it down here, go back to while, but like, it's just going to, it's going to break out of the loop. That's why it's called a break. So now we're going to do some if guess is equal to number and if guess is not equal to number. Now notice that I say is equal to, and I use this strange double equals, and then I say it's not equal to, I use the exclamation mark and the equal sign. So that just simply means is not equal to. The exclamation mark in a lot of programming is going to be the not operator. Think of it just kind of like logical opposite day. It's going to take whatever you're asking and flip it around. So if we say if true, well, that's kind of like our forever loop. Or we could say if true, which this evaluates to not true, which is false. It's weird, but like it makes sense as you get more comfortable with it. And the reason why we have double equals here is because this is what's called a comparator. We're making sure that these two are equal. If we just use a single equal sign, we assign the left variable, the right variable's value. So if we just did this, we would say, okay, guess is going to be equal to number. Even though we have this if statement here, the computer isn't really going to be smart enough in order to infer the context there. And so it's just going to say guess is equal to number. So whatever the value of guess is, it's going to be overwritten with the value of number. So we use the double equal sign to make sure that the computer checks as opposed to just filling the value. So if guess is equal to number, whoops. Okay. So guess is taken is going to be turned into a string. So we're just doing the opposite of what we did up here. We're taking an integer, guess is taken, and we're turning it into a string so that we can then print it to the screen. Well, good job. Let's do this. Plus my name, so that you feel more important. You guessed correctly in plus guesses taken guesses. There, so now it prints out a little victory message. It says, good work, good job, my name. You guessed correctly in, and then it prints out the guesses taken guesses. So, if it took us 4 guesses, it'll say, good job, your name, you guessed correctly in 4 guesses. Nothing too crazy there. We're just sort of taking the concepts that we used up here, and we're sort of we're expanding upon them. We're doing a little bit more with them. So if guess does not equal number, we're going to say number is equal to string number, and we're going to print sorry mate, number was actually plus number. And so now it'll say, sorry, the number was actually 7, or whatever the number actually is. But with this actually finishes out our program. I know I went a little bit faster at the end there, but I wanted to make sure we had enough time since it is getting pretty close to 8:50. I wanted to make sure we had enough time to sort of just run through it. So just as a quick run through of everything we've done again, and I'll go back to the bottom real quick so that you guys can finish typing it out, because I'm sure there's a couple of you guys that still need to type out the end there. Import random. Pull in the random library. Create a variable called guesses taken. Set it to 0. Get the name. Print the name. Fill number with a random number between 1 and 20. Then, as long as the number of guesses the user has taken is less than 6, so if we start at 0, that's going to be 6 guesses, confusingly. We're going to say, make a guess, get that guess, turn it into an integer, increment guesses taken by 1. If the guess is too high, we're going to tell them it's too high. If the guess is too low, the number is too low. If the guess is equal to the number, then we're going to bust out of the loop. But we're going to run this loop until either the user has made 6 guesses or they've guessed the correct number. Then once we bust out of the loop, we're going to ask if the guess is equal to the number, we're going to print a victory message. If the guess is not equal to the number, we're going to print a sort of a game over. So we go ahead and save that. And then if I was just to run this, guesses.py over here in the command line again, nothing particularly out of the ordinary here. I'm going to move this over so that you can still read the code. Boom, there we go. Nothing out of the ordinary. We're going to say our name is Eustace. And I was going to say, well, I'm thinking of a number between 1 and 20. Go ahead and make a guess. So I'm going to guess 8 and hit enter. And it's going to say that number is too low. So I'm going to go up to 18 and hit enter. And it's going to say it's too high because it's too high. I have no idea what the number is. 14. Still too high. How about 11? And there we go. That's what it was. Now it says, good job. You guessed correctly in 4 guesses because we guessed 4 times. Now let's say we did it wrong. My name is Dunce. I'm going to guess 1. That number is too low. I guess 1 again. Still too low. 1 more time. 1 again. Maybe it'll work if I keep trying it. 1. Finally, let's try 2. Oh, look at that. Game over. Sorry, the number was actually 9. So now we've got like a fully functioning thing. If we win, we get a victory. If we lose, we get a, oh no. It checks to make sure our number is correct. It gives us a little bit of guidance. It lets us know if the number is too low or too high. And it remembers our name, which is really, really considerate of it. So yeah, it's 8:50. I'm actually going to do the poll questions right now, but I'm gonna keep this the guesses notepad open, and I'm going to keep the command line open, and we'll leave it open for question and answer time, so we can go over everything, just so you guys can make sure that you have everything. But if your program is running and you feel pretty confident about everything, you don't have any questions or whatever, once we're done with the poll questions, you can go ahead and head out. Have a great weekend, and I'll see you on Wednesday, but obviously you'll be back for lectures on Monday. So here we go. First poll question incoming.